Recently, Toyota, the world's second largest car maker, announced a technological breakthrough that will allow it to reduce the weight, size and cost of batteries by 50% using solid-state batteries. Why is that a big deal? Most electrical vehicles use liquid or lithium-ion batteries, which are cheaper but more likely to catch fire. Solid-state batteries, on the other hand, are safer, require less charging time and have greater capacity. Toyota says its battery will have a range of 1200 km and can charge in 10 minutes or less. Due to this recent focus on solid-state battery technology, there is a high possibility that UPSC might ask a question related to this in the upcoming prelims. In previous years, UPSC asked questions on technologies that have been in the news. For example, in 2021, they asked how do sodium lamps differ from LED lamps. In 2020, they asked about visible light communication technology, that is the VLC technology. So, in 2024, there might be a question about the solid-state battery. So, to address this topic, we will be discussing the following three things in this video. The first one, what are lithium-ion batteries and how do they work? Second, what are solid-state batteries and how do they work? Finally, third one, how are solid-state batteries different from the current technology of lithium-ion batteries? So, let's first understand what are lithium-ion batteries and how do they work. To start with, a battery is a device that stores chemical energy and converts it into electrical energy when needed. Lithium-ion batteries are a type of rechargeable battery that powers many of our everyday devices like smartphones, the laptops, and even EVs or the electric cars. They are popular because they can store a lot of energy in a small, lightweight package and can be recharged hundreds or even thousands of times. In simple terms, here's how the battery works. Inside a lithium-ion battery, there are three main parts: the anode, the cathode, and the electrolyte in between them. The anode is usually made of carbon, like graphite, and the cathode is made of a lithium metal oxide. When the battery charges, lithium ions move through the electrolyte from the cathode to the anode. As the battery charges, it stores energy. So when you use the battery to power something, the lithium ions move back to the cathode from the anode, and in the process, they release the energy that powers your device. The electrolyte is a chemical medium that allows the lithium ions to move between the cathode and the anode, but it doesn't let the electrons pass through. This is important because it forces the electrons to move through the external circuit, that is, the device you are powering, which is how the electrical energy is delivered to your device. To recharge a battery, you apply an external electric current which reverses the discharge process. This pushes the lithium ions back to the anode, storing the energy from the electrical outlet back into the battery. These liquid electrolytes are prone to leakage, overheating, and are flammable. You may have experienced bulging batteries. These issues may be behind the apparent explosion of some EVs as well. Then, what are solid-state batteries? Like any other traditional lithium-ion battery, a solid-state battery also have an anode, a cathode, and an electrolyte. However, solid-state batteries, as the name suggests, use a solid electrolyte instead of a liquid electrolyte. This solid electrolyte can be made of different materials, but the key is that it's not a liquid. Solid-state batteries are considered an improvement over traditional lithium-ion batteries in several ways. Firstly, the safety. Since solid-state batteries don't have a liquid inside, they are less likely to leak or catch fire. Liquid electrolytes in lithium-ion batteries can be flammable under certain conditions, which is why you sometimes hear about battery fires. Solid-state batteries are much safer in this regard. Second, in solid-state batteries, the ions move along a solid material using the voltage differences. Since the ions are moving along its own crystal structure, it is easier and hence it takes less time and energy to recharge. Also, a crystal structure can pack more of the ions together, and in discharging, more ions are available. This means the more energy can be packed into a solid-state battery compared to a lithium-ion battery, which means solid-state battery has higher energy density than traditional lithium-ion battery. Fourth, without the need for bulky liquid containment, solid-state batteries can be made smaller and lighter, which is always an advantage for the portable electronics as well as the electric vehicles. Lastly, the solid-state batteries can last longer than lithium-ion batteries. They can handle more charge and discharge cycles before they start to lose their ability to hold a charge. This is why Toyota's announcement is very important. The range of 1200 km announced is nearly double the range achieved by the existing EVs using the lithium-ion batteries. Of course, it needs more research before the batteries completely replace the lithium-ion batteries. Toyota themselves think that they can unveil this technology by 2027 only. Meanwhile, UPSC may frame question in the following ways. The questions related to the working of lithium-ion batteries, materials used, etc. can be expected for prelims. For mains, the issues associated with lithium-ion batteries, safety issues of electrical vehicles, the potential of solid-state batteries, etc. can be asked. To get additional points and to cover this topic comprehensively, please refer the Yoda IAS workbook on this topic. Link to download the PDF is given in the description. So with this, we are concluding today's topic. See you in the next video. Take care and stay safe.